Good morning, children. Hope everyone is fine and safe. How was your test about of the lesson light, shadows, and reflections? Hope everyone has written it and the activity also is done. So take the paper after writing the test, show for your parents, get it corrected, file and keep it. Okay, and the activity also. Okay, children. Now let us continue with the lesson. Can you tell me last week which lesson I was taking? Yeah, electricity and circuit. So what did we study in the last chapter? We studied that we use electricity for many purposes in our daily life to make our tasks easier. So where all we use the electricity? To operate the pumps that lift water from wells or from ground level to the roof top tank, isn't it? Other than this, what are the other purposes where we use the electricity? Can you write them or tell them orally one by one? Yeah. So, electricity makes it possible to light our homes, isn't it? When light is there only in the home, you can see, isn't it? As soon as it is 6 o'clock, it is dark nowadays. So, as soon as there is light, you can see there is a light in your home and on the roads, offices, then markets, factories, isn't it? So here all electricity, through electricity only we are able to see all these things, to light up these things. So from where do we get the electricity? We get the electricity from the power stations, isn't it? Who will provide us electricity? Power stations will provide the electricity. Then sometimes the electricity will fail also, or you may not have the light suddenly. So what do you do during that time? What do you do? Yeah, you will use a torch. Nowadays you have this thing, inverters and all, we use that, isn't it? Earlier people used to use the chimneys or the torch or the candles so that the house would become everywhere black due to the smoke of the candles and all. But nowadays we have the inverters through which there is no harm. It is like electricity only. If the power goes also, it doesn't show any change. It works. Everything works. So these are the uses of electricity what we studied in the last class. So electricity is used for the communication purposes, that is computers, portable phones, radio, TV. Then heating or cooling. For heating we use the oven, iron. Then for cooling, refrigerators and air conditioners. Then for lighting we use the incandescent light, lamp, flashlight and floodlight, isn't it? Then for this thing, to run motion or the power, that is for the motors, for the cars, for the blenders and for the drilling. Here also we need the electricity, isn't it? This we had studied in the last class. Then what is an electric current? So what is electric current? What did we study? We studied that flow of electrons through a conducting wire in a unit time is called as the electric current. Then sources of electricity, batteries, generators. These are the sources of electricity. Then we said what are conductors. So electrical conductors and insulators. Then what are insulators? So let us find now. So conductors are materials that do not allow current to pass through, that is insulators, which will not allow current to pass, they are called as insulators. For example, through plastic current will not flow, through wood current will not flow, through rubber current will not flow, and even the glass the current will not flow. So only you might have seen an electrician, when he is working with the electricity, he uses a stool which is made up of wood or of plastic, and he uses the rubber gloves. So later on we'll study about this. Then materials that allow current to pass, they are called as the conductors. For example, salt water, metals such as copper, aluminium and non-metals like graphite, which is a form of carbon. So these are used as conductors. Through this the electricity will be flowing or the current will be flowing. Then here, what type of materials are good electrical conductors? whether aluminium, rubber or wood. So which is a good conductor? Can you tell me? Yeah, it is aluminium. How is electrical energy produced in the cell? So in the cell, how electrical energy is produced, that we are going to study. We studied already. When electrodes are placed in electrolyte, the production of electricity is by chemical reaction that changes the chemical energy into the electrical energy. We had seen the videos through which I showed you how the electricity is produced, which allows the electricity, how the cell, where the terminals allow the electricity to pass through it. We have seen that the production of electricity by the chemical reaction, that will change the chemical energy into the electrical energy. These are the batteries. Then we had seen the difference between the batteries. There are two types of batteries. One is primary battery, another one is secondary battery. Electrical energy is from the chemicals inside them. So what is electrical energy? Now, this energy is used by the chemicals which are present inside the batteries. This can't be charged. Once the chemical is over, you have to replace the dry cells. Okay, that is called as the primary batteries. Secondary batteries means here electrical energy is produced by chemical reaction, with the chemical reactions are reversible. That means they can be charged and again they can be used. So they are called as reversible, isn't it? So this is the difference between primary and secondary. These can be charged, secondary, but primary cannot be charged. Once used, you have to replace it. So here primary cells, all these, what all you use in the toys, in the torch, in the wall clocks, all these you use in the primary cells. Secondary cells used in the mobile phones, car, batteries, etc. This is the difference between primary cells and the secondary cells. Okay. Now solar or photovoltaic cell. How do solar panels work? So as the sunshine goes on a solar panel turns it into electricity. Can you see in the picture here? Yes. So how do solar panels work? So like this, nowadays we have, you see, even on the streets and all, on the poles and all, electrical poles and all, where you have the mercury bulbs, instead of that you have this solar panels. So through this what happens? Sun as it shines goes on a solar panel turns into the electricity. You can see on the roads also, on the poles, electrical poles. Then now let us see the working of a primary cell. So already you have seen a cell. Can you see? This is a dry cell. So here there are positive electrode, then this is a electrode paste, then you have a separator, then carbon and manganese dioxide mixture, zinc, that is a negative electrode. So here carbon is a positive electrode and zinc is the negative electrode. So here positive ions are called as cathode and the negative ions are called as anode. Already you have learned this in 5th standard. What are cathodes and anode? Positively charged particles are called as cathode and the negatively charged particles are called as anode. So cathode is the positive end here. So cathode, this is the positive end, and here the cathode is carbon. Anode is the negative end here, this, and here anode is the carbon and manganese dioxide mixture or zinc, isn't it? So this is the primary cell. Now flow of electricity is from positive end to the negative end. So on the cell you can see these two marks, positive end and negative end. So electricity, how it flows? From the positive to the negative. Hence in dry cell, the flow of electricity is from carbon rod to the zinc end. Just now we saw in the cell, isn't it? So how is the electric flow? From here, carbon to the zinc. So from positive to the negative. Then flow of electricity is from positive end to the negative end. Hence in the dry cell, The flow of electricity is from carbon rod to the zinc end. Now, what is a circuit? Now we have studied about terminals, positive terminal and the negative terminal of a dry cell. Now let us study about the circuits. The complete path for flow of electric current from one terminal to the other terminal is known as electric circuit. So can anyone define now what is electric circuit or a circuit? The complete path for the flow of electric current from one terminal to the other. Now here these are the commonly used symbols in the electricity. Can you see in the picture here? In the cell you have like this, I showed you in the cell, positive and negative. This battery in the mobiles and all, you can see a small line and one big line, isn't it like that? Then this is a key closed, means switch on. Key open, this is a symbol. Then tapping key, switch off, this is switch off. Tapping key closed, this is closed one. Then this is a bulb, filament. Inside the bulb you have a filament, that is the symbol bulb, it indicates bulb. Plus wires joined at the point, here this wires over tapping. Okay, so these are the commonly used symbols in the electricity. You should remember and you can use it. You can use in your daily life also, isn't it? When you are placing the cell and all in the toys and all, always you see, where it is positive and where it is negative. Then only you use the cells. Otherwise what happens? It will not start working. And here for the bulb also, if the filament is gone, inside you will have a thin wire, I said silver color. Once this is broken, then the bulb won't light it. It has to be replaced like this. Okay. Then now next, these are the switches. I think everyone is familiar with this. You have in your home. Every day you on, off, isn't it? Switch on and off. It will be written there. If you want on, you use it. As soon as you are going out, you off it, isn't it? Nowadays varieties of switches are there. Electrical switches control the flow of electric current. So here closed circuit and the current will flow. Already I showed you. Closed circuit means the current will flow. Off, here there is a gap between. So open circuit means the current will not flow. So these electrical switches control the flow of current. Then we have a torch, isn't it? You use the torch whenever you are walking on the road and all, when there is no street light and all, as you are walking you use the torch. So this is the torch. This is the inside view of the torch. Can you see here? See carefully this, so that you will know how it works, isn't it? So here you have first plastic casing, then here you have the metal switch contacts, then here you have slide switch, you know already, sliding on and off button, this will be sliding switch. Then here you have the metal spring where the cells or the batteries will be moved inside. Wherever you are placing in the toys and all, also you will have like this metal springs where you place this cells. Then C size cells connected in series. So here these are the C cells connected in the series. Series means what? One should be positive and one should be negative. So here positive, then next should be negative. Here you can see this. This is positive and this is negative. Always you will not place positive, positive, negative, negative. You will place it as one positive and one negative like this. Okay. Then this is lamp contact. This is lamp filament. This is a reflector. This is a water resistant sealing ring. Okay. These are the parts of the torch. You can see it clearly. You have the activity which you have to do on the torch. You have to draw this torch and label the parts. And one more important thing is this. Here you can see this part, this metal spring, isn't it? After the spring, here when it is connected, here you have to show one red line. Here bulb is there. Lamp filament means here bulb will be there. So if you show it in the red color when they are connected to the batteries, what happens when it is complete? When you switch on, the bulb will glow. So you have to show that with the red color whether the bulb is glowing or no. So once the cells are finished their chemical, they will not again make the bulb to glow. They have to be replaced. So if the shells are new, then only the bulb will glow. If the shells there is chemical inside, then only the bulb will glow. Otherwise the bulb will not glow. You have to replace the cells. Okay, this is about the torch. Now let us study the part and the functions. Now which part? Bulb. You might have seen in your homes also. What it does? What is its function? It produces light. Reflector and lens. What it does? It helps to focus the light. Plastic body holds the parts. Plastic body means wires and all in your home you might have seen. Even mobile chargers and all, when we are charging, you see how up you have the plastic body, isn't it? So those are called as the plastic body. They hold the parts. Switch, it will control the flow of current. Battery, it will give the power. So these are the functions. These are the parts and these are the functions of the battery, what we studied just now. About the inside view of the battery we have studied, that it is. So bulb, what it does? Produces the light. Reflector and lens helps to focus. Plastic body holds the parts. Switch controls the flow of current. Battery, source of power. Okay. Now here are the parts of a light bulb. You might have seen a bulb in your home, isn't it? Now these are the parts. Can you see the bulb here first? First is glass bulb. So this whole thing is, this is the glass bulb. Then next, second one, this is the low pressure inert gas. So this is the low pressure inert gas. Then here this is the tungsten filament. Okay. Then fourth one, this. Here you have the contact wire. Okay. Then you have contact wire. Fifth one. Again you have two contact wires. Goes out of steam, goes into steam. So this will go out of the stem and this will be inside the stem. Okay. Then you have support wires. Sixth one, this here, these are the support wires. Then what do you have next? Stem glass mount. This is the stem glass mount, seventh one. Then eighth one is contact wire. These are the contact wires. Then ninth one is cap. 10th one is insulation. Then this 11th one is electrical contact. So there are nearly 11 parts of a light bulb. Okay, you can see and identify the parts one by one. Daily two parts you can read and remember the parts. Okay. So now let us see this thing, smart board. Okay, children, let us see the smart board and understand about the electric cell. Then what it is. We have to study about the electric cell with the 2 wires attached. Then let us study about the different arrangements of electric cell and bulb. Then direction of current in an electric circuit. Then a homemade starch. Then electric switch, that is a simple switch, an electric circuit with a switch in a on position, off position, and the inside view of the torch. Let us see through the smart board, okay, or the animated pictures.
We have seen that electric cell and the bulb have 2 terminals each. Why do they have these 2 terminals? Let us try to make an electric bulb light up using an electric cell. Here we have taken an electric cell and torch bulb. Let us connect both with the 2 terminals in all possible ways. Here the positive of the cell is connected to the one terminal of the torch bulb and the other terminal of the bulb is connected back to the negative terminal of the cell. We can see that the torch bulb glows and the current flows through the circuit. Similarly, check the different connections and observe if the bulb glows and current flows or not. We can see that the bulb glows only when both the terminals of the cell and bulb are connected to each other without a break. This is how we use the terminals of the cell and battery for electric lighting purpose.
Kids, a bulb is the most commonly used source of light. So today we shall learn how to light a bulb using a cell. The bus fills petrol from the petrol pump and thus petrol pump supplies it energy. Then how does a cell supply energy to bulb? As you know, bulb needs electric current to glow. An electric cell produces electricity from the chemicals stored inside it. When we connect the cell properly with the bulb, the chemicals produce electricity. Look at the cell closely. One side is marked plus, that is positive, and the other side is marked minus, that is negative. Why is it so? If you observe the cell closely, it has a small metal cap on one side and a metal disc on the other side. The metal disc is the negative terminal and the metal cap is the positive terminal. To recognize the positive and the negative terminals of the cell easily, one side is marked plus and the other side is marked minus. All the electric cells have 2 terminals, a positive terminal and a negative terminal. And how does the electric current flow reach the bulb from the cell? Yes, through the wires, or more precisely through the circuit. Before that, let us understand the bulb, which gives us light a little bit more. Look at the bulb a little closer when it is switched on. A small piece of wire in the middle of the bulb is glowing and emitting light. This small piece of wire is fixed in the middle of the bulb. It is called filament. The filament is fixed to the two thicker wires which also provide support to it. One of these thick wire is connected to the metal case at the base of the bulb. The other thick wire is connected to the metal tip at the bottom center of the base. Now, how would we connect a bulb to a cell to make it glow? If we just connect any part of the bulb using wires to the cell, say the part made of glass, would the bulb glow? No. So, there are fixed places on the bulb which we have to connect with the ends of the cell to make the bulb glow. The first place is the screw marks on the metal base of the bulb. The second place is the tip of the metal base of the bulb. These places are called terminals. So, like a cell, the bulb also has two terminals. To reiterate, the base of the bulb and the metal tip of the base are the two terminals of the bulb. Both of these terminals have to be connected to different ends of the cell so that the current can flow through both the terminals of the cell to make the bulb glow. Now we know where to connect the wires in a bulb. Let us help the electric current to reach the bulb, otherwise cell would be useless and wouldn't make the bulb glow. Now let us make a path for electric current to flow. Connect an electric wire to the positive end of the cell. We can use rubber bands or tape to fix the wires to the cell. Now, connect the other end of the electric wire with any terminal of the bulb. Say, we connect with the terminal which is on the metal base. We can stick the wires to the bulb with the tape used by the electricians. We already know about conductors and insulators. So, the tape and rubber band are insulators and hence we use them for fixing wires. We made arrangements for the current to reach the bulb. But still the bulb is not glowing. Why? Because the cell is not connected to the second terminal. Besides, current cannot come back to the cell, so the circuit is not complete. Let us make the path for current to flow back to the cell by connecting the negative terminal of the cell with the other terminal of the bulb. For this, connect a wire to the other terminal of the bulb, say the tip of the metal base, and connect the other end of this wire with the negative end of the cell. Look, the bulb is glowing. Wow! That means the circuit is complete. What if we reverse the connection from the bulb to the cell? That is, the terminal which was connected to the negative terminal of the cell is now connected to the positive terminal of the cell and vice versa. Well, the bulb still glows. That shows the bulb doesn't have positive or negative terminal like a cell. We started making the path from positive and ended at the negative end of the cell, not same end of the cell. What if we connect both the terminals of the bulb with one end of the cell only? That is, either both of the terminals to the positive terminal or both the terminals to the negative terminal of the cell. Would the bulb glow? It seems like it should glow because there is a closed or complete path visible. But the bulb won't glow in both the cases. And there is a valid reason for it. We all know current flows in a fixed direction. In the case of cell, the current flows from the positive end to the negative end. So, we need to provide that path between the positive and the negative end of the cell in order that current flows through it. Current reaches one terminal of the bulb from the positive end of the cell and then comes back to the cell through the wire connected to the other terminal of the bulb. Now we know both the terminals of the cells need to be connected to the bulb to provide the complete path for the flow of electricity. When we reversed the wire connection from the bulb to the cell, still the bulb glowed. How? Here again in the cell, the current flows from the positive end to the negative end, as both the terminals of the cell are connected to the bulb to provide the complete path for the flow of electricity. What would happen if the wire is cut?
Now we are going to learn how to make a simple switch. To make a simple switch, we need a small block of soft wood, a paper clip, 2 metal drawing board pins, 3 pieces of insulated wire, a small bulb with holder and a battery. Here is the method. Attach a piece of wire to each board pin and push one board pin into the flat side of the wood. Push the second board pin at the end loop of the paper clip and into the board at a distance of 1 centimeter away from the first drawing pin. Now your switch is ready. To test the switch, connect the free end of one of the wires to the positive terminal of the battery. Connect the third wire to the negative terminal of the battery and to the bulb. Now connect the free wire from the switch to the other side of the bulb. Turn the paper clip such that it touches both the drawing pins. The bulb glows and the switch is ready. Conductors and insulators. Connect the circuit using a battery, a key, a small bulb, and a wooden scale using connecting wires. When you switch on the key, the bulb doesn't glow. Now, instead of wooden scale, connect a metal key to the circuit.
cell or a dry cell is the source of electricity for the bulb to glow. Let us know how the bulb in a torch glows. Step 1. Take out the bulb from a torch. You can see that the bulb is a small globe of thin glass, inside which a coiled filament is fixed on two thick wires. One of these thick wires is connected to the metal case around the base of the bulb. The other wire is connected to the metal tip at the base of the bulb. The metal case and metal tip at the base are two terminals of the bulb. Take two pieces of half-meter long insulated wires. Remove the plastic covering at the ends of each piece of wire with the help of a knife. Now fix the bulb on a bulb holder. Then two screws on the bulb holder become two terminals. The insulated wires are connected to the two terminals on the holder as shown in the picture. Finally, connect free end of one wire to the positive terminal of the cell and free end of the other wire to the negative terminal of the cell. This may be done with the help of a rubber band or an adhesive tape. After the connection, you can see that the bulb lights up. Closed and open circuit. If you see both the wires are connected to both the terminal, it is an unbroken path. It is a closed circuit. Disconnect one of the wires. You will find that the path is broken now. Also, the bulb doesn't light up since electricity can't flow through this circuit. A broken path is known as an open circuit. Electric switch. We put a switch on or off whenever want to use or not the electric appliance such as the fluorescent tube, fan, AC, etc. A switch for a bulb is pressed down to complete a circuit. The bulb glows. To put the bulb off, we press the switch up. This breaks the circuit and the bulb glows no more. The switch is so made that under normal conditions, the circuit remains open. The current does not flow through the circuit. When we press the other end of the strip on the switch, it gets connected to close the circuit. The current flows through the circuit and the bulb starts glowing. A switch is a device to close or open a circuit. Summary. Let us summarize what we have learned. An electric bulb glows when electric current passes through it. A closed circuit allows the electric current to flow through it. An open circuit is a broken circuit and the electric current does not flow through it. A switch is a device to close or open a circuit.
Have you ever thought of all the ways you use electricity? We depend on electricity to light our homes, charge our phones and computers, wash our clothes. It powers our lives. But electricity can also be dangerous, even deadly, when used the wrong way. Keep these electrical safety tips in mind to avoid accidents and injuries. Electricity and liquids do not mix. Never place electronics and appliances near water, like next to the sink or the tub. This tip applies to gaming equipment too. Never place a drink near your gaming console. Spills could result in electric shock. Never climb trees near power lines and electrical equipment. Same goes for kites and drones. Before you fly them, make sure you're far away from any overhead power lines. Never pull a plug from an electrical outlet by its cord. Pull from the plug to avoid potential shock, or ask an adult to help you. Going for a swim? Remember, never swim during stormy weather. If you hear thunder, immediately exit the pool until the storm has passed. These are just a few tips to keep in mind. Remember, electricity is a myth.
Hope everyone might have seen the video and followed the lesson better, isn't it? Video has shown all the experiments to do very clearly or the activities to do very clearly. You can try at home in front of your parents and do it. Okay, children, and already FA3 test portion is given to you all. Please be reading and read the lessons you read. In between, any questions will be asked to you. Read the lesson, and whatever PDF questions are given to you, read that also, and be prepared for the test. Okay, let us continue the same lesson in the next class.